for your kind effort to introduce me. Okay, so now we'll be starting our session. Just to remind you guys, we will be doing the first hour. We'll be talking about a lot of conceptual things, and then the second hour we'll have a small break, and then the second hour we'll be doing the actual analysis using SmartPLS, which is one of the softwares for PLSM analysis. And last 30 minutes or 20 minutes, we will be doing sort of feedback or questionnaire session. So let's start it. Okay. Bismillahirrahmanirrahim. Okay. Okay. As Dr. Mehdi has already introduced me, let me give you my brief introduction again. My name is Dr. Kashif Farhat. I have PhD in marketing from University of Uttar, Malaysia. Just quite recent, actually, just last year. Currently, I'm serving as a senior lecturer at Muhammad Ali Jinnah University, Karachi, Pakistan. My forte actually lies in marketing, brand management, strategic marketing. This is something that I've studied, I've taught for the last 10 and 12 years. And even professionally, this is what I've done. I've done mostly sales and marketing jobs in my life. I actively publish, and if you go to my ResearchGate profile or go to my Google Scholar profile, you'll be able to see a number of research that I've published, even though quite recently I did my PhD. Okay. However, like anybody else, I have a lifetime commitment to research and publish and contribute back to the society. So let's, okay. Now, starting our presentation, our workshop today. Well, I believe all of us understand that my workshop is going to be about PLSM, which is partial least square structural equation modeling technique. Now, I don't know how many of you are familiar with it, but I'll try to give you some very basic concept of it, and then we'll jump on to doing it actual work, right? And what I did, I'm sure Dr. Mehdi has provided you a sample data of 100 people, because this software that we'll be using is called SmartPLS. It's a paid software, and assuming that many of you may not have access to paid software, I provided the link to download it and use the student version of it. Now, the downside of using student version of it is that it doesn't allow to run data more than 100 responses, more than 100 cases. So for this, I already provided 100 cases or 100 responses sample file to Dr. Mehdi, and I believe most of you would have received. Okay, so let's go straight. So this is what we'll be talking about today. This is sort of loose outline of what we'll be talking about. We'll be talking about what is a construct, and then we'll talk about what is PLSM, what is CBSM, and then we'll talk about what are the objectives of running or using PLSM. And then we'll be talking about PLSM assumption, and then how to specify the model, and then how to conduct measurement model assessment, and how to conduct a structural model assessment. So most, give or take, our discussion will remain around these points. Okay. And then we'll be talking about the variance effect size and blindfolding, of course, as part of the structural model. Okay, so hoping and assuming that if not all of you, most of you would have already set up the SmartPLS for their, for the analysis. If not, there's no harm. You can just stay connected to us. You can just look at what I'm doing. And while I'm going through this presentation, remain solid, or you can just, look what I'm doing. And later, when when Dr. Mehdi provides you the recorded link of this video, of this session, I believe you'll be able to follow. It's recommended that you have access to this software. It's called SmartPLS, and you have access to the file I have provided. You have imported that into your SmartPLS software, so you can run different analysis along with me and have what we call some hands-on experience while we are going through various detail of it. Okay, So the first hour will be all about conceptual part, and the second part will be about running SmartPLS, doing different analysis. Okay, number one. Now, what is a construct? A construct is an abstraction of phenomena, thing, object, concept measured by direct observation. Well, we need to understand that we people, especially the people who belong to HR, project management, marketing, in many cases, what we are doing is that we tend to do research based on various ideas, various concepts we call. Now, those concepts actually, those concepts in research, we may want to call them construct, actually. We call them construct. Constructs are actually those concepts that we measure by collecting certain type of data. For example, we could have a construct called motivation. We could have a construct called visual acuity, and we can have a construct called justice. We can have a construct called problem solving ability, hunger, satisfaction, loyalty, employee retention. All these are actually concepts. So what we do, we have a way of measuring these concepts. We have a way of measuring these concepts, which essentially means that any concept, such as even happiness, because it's a concept, it's an idea, what we can do based on expert knowledge, we can develop various type of statements called items, and we can measure these concepts using those items. So if you want to understand what is motivation, whether somebody is motivated or not, whether motivation has effect on the employee performance, whether motivation has effect on purchase intention. Well, there are ways, there are skills available for them. So, which essentially means that in primary data, I'm talking about specifically here, the primary data type, when we collect primary data, mostly, not always, mostly we collect primary data for these, constructs, which we call psychometric construct or psychometric scales, in which basically we try to measure different type of concepts. So, like I said, happiness is a concept. Loyalty is a concept, satisfaction is a concept. It's not a tangible thing such as sales figures, such as employee retention ratio. Those are, the actual data. Those are the, we call discrete data. In comparison, this data, that mostly somebody who belongs to marketing, somebody who belongs to HR, management, strategic management, all these various concepts that we are calling here as a constructs. These concepts. So that's what we need to understand. That the constructs, variable, all these are the same thing. These all are the same things. Now, moving forward. So we have various type of variable. That means we have various type of constructs. We have dichotomous variable, such as gender, male and female. We have polytomous. We have continuous. We have categorical variable. We have observed variable. Then we have latent variable, and then we have independent variable, dependent variable, mediating variable, moderating variable. So somebody who plans to do a primary research, whether for their thesis or they're doing for their publication, they need to understand that basically there are many types of construct, there are many types of variable, there are various ways of measuring any concepts, right? Usually what we do in research, that whatever the available scale is available, whatever the scale is available in the literature, we would pick that, we choose that, right? Now, when we use that, we need to understand that those available scale could be of various type. Those could be categorical variable, they could be latent variable, so much and so on. So when we are collecting the data, before we plan any study, we need to understand that, we need to be very clear whether are independent variable, dependent variable, mediating variable, moderating variable. What is the nature of these variables? Are they categorical variable? Are they continuous variable? Are they latent variable? Are they observed variable? For example, I said, the height, the height of a person or the weight of a person. These are observed variable, right? They can be directly measured. In comparison, when we talk about, I'm referring to here, latent variable. So when we talk about latent variable, these are the variable like I talk about happiness and satisfaction and loyalty. These are latent variable. That means these are hidden variable. So what we do in mostly in primary data research, we are concerned about these two types of variable: observed variable and latent variable, right? And these observed variable or latent variable, in many cases, could have dichotomous variable. That means they could be categorical variable, or they could be just a concept, right? And you will understand it better when we move on to the next slide. Take a look at here. What is happening? What is happening here? Here I have a concept. In other words, I have a variable called social status, and apparently the social status is. Let me take highlighter so you can see. Okay, so we have social status here, and these item number 1, item number 2, item number 3, item number 4, and 5. Basically, these are called statements, right? These statements help us capture, or rather measure this concept, which is called social status. So what we are actually interested in a research maybe is that we want to measure social status. In order to measure social status, we will measure item 1, item 2, item 3, item 4, and 5, which are actually 5 statements. And now where we are taking these statements, basically we take these statements from available literature. That means social status scale is already available in the published research, and we can take that. Okay, and think about it. This type of questionnaire we often use to collect data. We often use this type of questionnaire to collect data. So I was talking about item. So this is one item, and I was talking about item. This is second item, and usually we give them this 5-point Likert scale or Likert type scale, where we ask respondent to respond to our questions. So often what happens is that when they select agree, disagree, we collect all these data, and then we put them on an Excel sheet, and then we run some type of analysis to understand whether the collected data verifies or supports our relationship or not. So when we have situations like this, social status would be called latent variable, and these items would be called observed variable, right? And this is extremely important for us to understand for somebody who's doing primary research, because now the latest modeling techniques is overwhelmingly about latent variable. Earlier, when they were using just the regression, what they would do, they would collect the data just on item 1, item 3, item 4, item 5, and they will take a mean value, which is an average value of everything, and that's how they would run analysis. However, things have changed now. The concept is that, listen, they're collecting the data. They're collecting the data for all these 5 items, and using these 5 items, they're trying to predict the social status, which is the latent variable. That means we cannot measure social status directly, but through these items. And these items are called observed variable. We call them observed variable, and constructs like this we call latent variable. Let's move forward. Another example. So we could have another situation where, let's say, we are interested in measuring source credibility. This is our latent variable. And source credibility, according to the theory, according to the available literature, they say source credibility has three dimensions. Means the concept of source credibility is made up of three dimensions, three other variable, three other constructs: expertise, objectivity, and status, right? So in this case, the first one is latent variable. The status, objectivity, expertise, there are also latent variable, but they are the dimensions of source credibility. They are the dimensions of source credibility. Sometimes they refer dimension as elements also, a couple of other names, right? So if somebody wants to measure source credibility, they'll have to measure expertise, objectivity, and status, which they themselves are actually concepts. And these concepts themselves will be measured by observed variable here, item 1, item 2, item 3, item 4, item 5, which actually are the statements. Somebody, on a questionnaire will give you, okay, I like this, I'm satisfied with this, well, I like to recommend this. So we collect all those 5 statements, and then we based on Likert scale or other type of scales, and then we try to see if these scales are relative status. And once we have done it all for objectivity, expertise, then we can say that, okay, we are able to measure source credibility, or we have been able to assess the relationship between source credibility and any other variable that you want to do it. So in primary research, this is what we are doing actually. Whatever area the participants of this session belong to, if they belong to primary research area, this is what they need to understand. They need to understand the idea of latent variable. It means the variable that we cannot measure directly. We have to measure these type of variables such as loyalty, happiness, satisfaction, brand identity, brand perception, brand image, by either by dimension based on the literature, or even if we are doing it through dimension, those dimensions will have their own items, We call them observed variable. Usually these observed variable are the statement that we collect on a questionnaire, a Likert scale questionnaire that we develop for our research. Let's move forward. Okay, so what do you mean? Okay, what do you mean by data analysis technique? Often we see, in any thesis will have 5 chapters. Chapter number 1 is introduction, chapter number 2 is literature review, and chapter number 3 is methodology, and chapter number 4 is results, where we run data analysis. So what we need to understand is this is a PLSM that we'll be talking about today, is a type of structural equation model. It's called SEM, right? Earlier, so structural equation modeling is a type of data analysis technique that we use in our chapter 4, right? Or is a type of data analysis technique that we use to measure or to assess the results of our research that we do in any research study. PLSM, or structural locational modeling, is a second generation technique. Earlier regression and many other type of techniques were quite common, such as cluster analysis, exploratory factor analysis, multidimensional scaling. These were very, very common. Likewise, multiple regression, logistic regression, ANOVA, which is analysis variance. These are very, very common, and it's still, they're extensively used today. However, PLSM, which actually belongs to structural equation modeling technique, it is a second generation technique because it's a much more advanced. It offers, it is able to address various issues which lied with primary exploratory studies, such as confirmatory studies, and primary exploratory studies such as regression. PLSM doesn't have those issues. Nonetheless, multiple regression and other type of regression is still pretty useful. However, PLSM is a second generation technique, and it allows to do, it enables research to do various things which we are not able to do just by using simple regression analysis or simple OLS analysis, which is called ordinary least square. Okay, so now in SEM we have two types of structural equation modeling is one type of analysis, data analysis technique. In structural equation modeling, we have two types of technique. One is called CBSAM, covariance-based structural equation modeling, and the second one is called partial least structural equation modeling. And PLSM it's also called PLS path modeling. So don't be confused if you if you see somewhere PLSM path modeling, you say, well, it is a different thing. No, it's not a different thing. PLS path modeling either is referring to CBSAM, covariance-based structural equation modeling, or it's referring to PLSM, partial least square structural equation modeling. So now, talking about what is CBSAM or what is PLSM, to give you to put this perspective in a very, very simplest manner, CBSAM is usually run with the software called AMOS, AMOS, AMOS. You may have come across that. It's usually used to confirmation, to confirm and reject theories, right? So something that has been studied many, many times, you collect that data and you try to study that in a different environment, such as, for example, the relationship between satisfaction and loyalty has been studied in tourism, and now you want to study the same relationship between satisfaction and loyalty in airline, let's say, among airline customers. So now this type of research is called confirmation research, right? Or model testing. It's also called model testing. Now in that we can use CBSAM. The idea, the main difference between CBSAM and PLSM is the difference between covariance. It's a concept called covariance, which is quite similar to correlation. And so the CBSAM is based on covariance data, and PLSM is based on variance data. The variance, how to take variance in the statistics. If you don't know, you can just go and take a look at what is variance in statistics. So PLSM is about variance and CBSAM is about covariance. So PLSM has a different way of calculating the data, and CBSAM has a different way of calculating the data. CBSAM is good for confirmation of theories. PLSM is good for exploration and development of theories, right? Okay, so what CBSAM, what SAM, right? Not the CBSAM, what SAM, structural equation modeling, it's not a single technique. You need to understand that it's a combination of various type of techniques. For example, measurement theory is there, factor analysis are there, path analysis are there, regression is a part of structural equation modeling, and then simultaneous equation is a part of structural equation modeling. So this is the reason we say it's a much more advanced, data analysis technique than the older way of ANOVA, t-statistics, logistic regression, OLS, ordinary least square regression type of thing. Okay. So what we can do in PLSM allows us to conduct direct relationship as well as mediated relationship, and we'll be talking about that in a while. What do we mean by that? PLSM over the year, whether it's PLSM or CBSAM, both have been very, very popular over last 1 decade. And specifically PLSM, recently in the last 5 or I would say 7 years, you'll see that PLSM has become the most preferred data analysis technique amongst researchers of various fields, such as marketing, human resource, psychology, entrepreneurship, strategic management, and even construction. You will see wherever we have this concept you want to measure, different type of concept, you will see PLSM as one of the most popular, is one of the most famous and practice technique. Okay. Okay, so let's talk about the objective. You'll see that here we have two types of PLSM and CBSAM. So we have, for PLSM, the objective is prediction, basically. When we're looking to predict the model, we're interested more in what we call causal prediction, causal predictive modeling. Well, then for them, PLSM is very good. But on the other hand, if you are just want to confirm what some, a relationship or any concept that has been confirmed in any other area, in any other type of research, and just want to confirm that again in a different environment, in a different context, well, then probably CBSEM is a better option for you, which is Amos. PLSM is a variance base, while CBSEM is a covariance base. PLSM does not have the assumption of what we call normality of the data. Non-parametric means PLSM does not believe or does not assume the data is normal. While in comparisons for CBSEM, we need normal data. We need, the data we collect, it has to be normal. And we will be talking about that. What do I mean by that? Okay, then PLSM allows you to do both reflective and formative type of measurement, formative type of constructs. In comparison, CBSEM is only good for reflective. Implication, well, Brother Mehdi, I hear somebody has this. Okay, thank you. Whoever is trying to turn on his mic is requested to please keep his or her mic off so I can continue with my presentation. Okay. So CBSEM is good only for reflective, while PLSM is good for reflective and formative both. And that's one of the major advantage PLSM gives you. Implication, PLSM is looking for prediction of accuracy, while CBSEM is looking for parameter accuracy. And again, parameter accuracy means, we just want to see if the data is the same as it has been observed in any other research. PLSM allows you to run very complex model and probably constructs as many as 100 and indicators which mean item as many as 1,000, even though it will require a very good computer or very high specification computer to run it. Nonetheless, the software allows you to do that. Not just the software, also the technique is also able to run such complex modeling. And nonetheless, I don't recommend anybody using that many constructs in their model, because theoretically, then you will be going away from the concept of called parsimonious, right? The parsimony in any research is very important. Parsimony means don't try to add too many constructs in any research model. Try to keep it, probably as less, probably around 10, not more than 10. There is no specific number to it, but I would say, 10 constructs or 10 variables in a model in a study are more than enough. Okay, so CBSEM is usually recommended for less than 100 indicator, and usually not, if the model is very complex, CBSEM is not recommended for that. Sample size, again, PLSM has another advantage. It allows you to run sample on a very to run analysis in a very small sample size, even sometimes as small as 30, 50, 100, right? However, we have to do some type of analysis before we determine what is the right sample analysis, and I'll be doing that today. In comparison, CBSEM, it requires you to have large sample to get the valid results. Okay. So let's go further. PLSM, you can run using SmartPLS that we'll be using today, WAR Plus, R package, Idenco, in comparison, CBSEM, Amos, Literal, M Plus, R square packages, Equus, OpenMX, all these softwares are known for CBSEM. So keep in mind, if you're using Amos, Literal, MS, M Plus, impossible. You cannot run PLSM in that. They're only good for CBSEM, covariance-based structural equation modeling. But if you're using PLSM, that means if you're using SmartPLS, you'll be able to use PLSM, right? So these two different techniques, PLSM and CBSEM, have been adopted by different software as well. So there are softwares who only run CBSEM, type of analysis, and there are software who only run PLSM type of analysis. And SmartPLS is quite famous for PLSM, probably the most famous software for PLSM. Okay, let's move forward. So should you use PLSM or CDSM? Right, that's the real question. That's a real question. Very simple. If your argument is prediction, you want to predict a different type of variable using one concept. You want to predict your dependent variable, which is one concept, and by using various concepts, then I would say yes, you can use PLSM. But if you just want to do model testing, we just want to verify, we just want to validate the results in any other environment already has been done, and you want to validate the results in a new environment, such as in your research, there's nothing new you're doing. All those relationships have been tested before. It's just a new environment. You want to test them. Then I would say you're doing structure analysis, rather structure verification. For them, CSAM is better. So the primary purpose of PLSM approach is to predict indicator by means of component expansion. In line with this notion, I here recommend that if the goal is predicting key target construct or identifying key driver constructs, like PLSM. In comparison, if the goal is testing, theory confirmation, or comparison of alternative theories like CDSM, right? Likewise, if the research is exploratory or an extension of existing structural theory, select CDSM. So when we are doing our research, usually when we start doing our research, when we start doing literature, we don't know about it. We don't know about it. But this is something at the time of methodology, chapter 3, we need to be very clear. That means the objective of our research is exploratory or confirmatory. Because based on that, we can decide what type of analysis we are going to do. Based on that, once we understand what type of analysis we need to do, then we can decide what type of, what is the sample size we need to collect, so much and so on. So once you are down to chapter number 3, methodology, I would say you need to be very, very clear whether the objective of your research is exploratory or confirmatory, right? In case you don't know, you wanna consult with your supervisor, you wanna consult with your seniors, and you wanna consult with some senior researchers, whether in your country or abroad. Usually these educationists, these researchers are very responsive, they're very helpful. Contrary to what many people think, that if they email any renowned researcher, they may not get any attention response. Well, my experience, contrary to this, has been completely different. I've been able to contact and I've been able to talk to some of the some of the top tiered researcher in the world of business management and social sciences, just by writing an email to them, and in a day or two I got the response. And sometimes I got the response within an hour. So something, if you don't understand, I would recommend you consult with your number one, consult with your supervisor, and after that you may want to consult with senior researcher. Okay, so PLSM, let's get ready. Number one, when we're doing PLSM, number one, we need to know the objective of the research. Confirmatory or exploratory or predictive. PLSM is good for predictive modeling. PLSM is good for exploratory modeling. For confirmatory, there are a large number of scholars who argue that PLSM is not recommended for them, rather CDSM is recommended for them. Okay, nonetheless, you will see in published research, even in some top journals, you will see many people have used PLSM for confirmatory research, right? And so really you need to, before you run PLSM, you need to know what is the objective of your research. Number two, you need to know the sample size. You need to determine the sample size. Number three, you need to treat the missing values. You need to understand if there are missing values in your data, how to treat them. Number four, distribution assumption. You need to know whether you have this issue. If you think you need normality, for example, your data is 100% normal, or you're really concerned about the normality of the data, then PLSM probably is not the right technique for you, right? Nonetheless, that doesn't mean PLSM cannot run normal data. It can, it just does not require normal data. And I'll be showing you what do I mean by normal data. Likewise, it's recommended not to have outliers in your data. Likewise, multicollinearity means high correlation amongst the constructs that should not be there. And otherwise, you're going to have, you're going to have increased error. Because we're going to all these aspects will inflate the error in our data. Another thing called unobservable heterogeneity that should not be there as well. And lastly, common method bias. So before we conduct PLSM analysis, we need to be very clear about these things. We need to be very clear about these things. So my objective of today's session is to try to do everything as much as possible. Try to do everything within SmartPLS. Okay. Before we talk about it, okay, number one, sample size. They say it's recommended that you have, the safest approach is to have 10 times whatever the largest number of structural parts you have, whatever the largest number of, structural path. That means whatever the largest number of, let's say you have one BV, one dependent variable, you have 5 independent variables. So in this case, you have 5 structural paths. So just multiply by them by 10, and this is the smallest number of sample size you need to run PLSM. Other way around is that you can use a software called G-Power analysis. So free software, just download it. If you don't want to do that, there's another way. Just go to this link I've given Daniel Soper, and you just go to this link and use a priori. It's called a priori, APRIOR. A priori calculator for structural equation modeling. Just find out the mini calculator, and do your sample size. Now, whatever the minimum sample size you need, you can get that from there. However, it's a good idea to always be a little 10% above, or 5% or 20% above the whatever the minimum sample size you need. Okay. Missing values in your data. When you collect the data, it's often the case we get missing values in our data. And for that, what is recommended that you need to have less than 5% for each indicator. This is what recommended is. Another way people say that if for any response, let's say you have respondent number 55, and you see that you have given him total 100 items to respond to, belong to the various concepts, and you see that 20%, at least 20% of them he has not or she has not answered. If it's more than 20%, I would say remove that whole response from your data. Other way around, for each indicator, the missing values should be less than 5%. Okay. In case you have missing value in your data, number one, it shouldn't be. If you have it, SmartPLS allows you to treat them automatically, and I'll show you what do I mean. Okay, then distribution assumption, normal distribution are not required. Nonetheless, your data should not be highly skewed. That means if it's highly, it's extremely non-normal, then obviously you're going to have it's going to increase error in your data. So slight abnormality in your data, slightly abnormal data is fine, nothing wrong. But if it's highly skewed data, right or left, well, that's not recommended. You need to treat it. Okay. Outliers, you can do, so again, you need to, before you run your analysis, you should be checking outliers. And for outliers, and I've highlighted here Mahalanobis test in SPSS. If you go to YouTube, you'll find out how to run it. Just write Mahalanobis test in SPSS in YouTube, and you'll see how to do it. This is a multivariate outlier technique, and you should be able to do it. Okay. Unobserved heterogeneity, FIMIX, again, it's an option available in PLSM that we can use to check unobservable heterogeneity. Okay, so if you have the famous model, the famous sampling table by Curtis and Morgan, If you have a probability, let's say you are collecting data by using probability sample design, then this the table should help you, right? So use this table. So let's say you have your population size is over 1 million, then you need minimum, and your the confidence level you want is 5%. That means the alpha is 5%. Then you need to have 384, minimum 384. So if you want to have 95% confidence level, then you need to have minimum 384. Likewise, let's say you want to have 1%, like you want to have 99% sure of your data, then you need to collect this many number. That means 9,512 sample size you need to collect. Okay. Usually we follow 5% in primary research, in business research, in management research. Usually we follow 5%. And usually what we do, we had probably 10% or 5% to 384 if your sampling technique is probability sampling. If your sampling technique is not probability sampling, then just simple use G-power analysis software, which is a free one, or Daniel Super, which is an online free calculator. Okay. So this is what I was talking about: normality of the data. The data, the bell shape you see in the middle. This is called normal data. That means it's equally distributed on both sides, left and right. We call symmetric distribution. On the other hand, on the left side, you see on the left, or on my left side, you see positively skewed data, which is again skewed data, and on the right side you see negative skewed data. So you see negative skewed or positive skewed, all are fine. But if it's too skewed, that is not fine, right? If it's extremely skewed on the right side or extremely skewed on the left side, then it's not fine. Then you need to do some type of normality analysis, number one, or the other way, there's a treatment, there type of treatment you can run to normalize your data. Okay, let's move forward. Outliers, you can make plots, scatter plots in SPSS to identify outliers. So either you can do manually, just by like this, you can make a scatter plot and you can see, identify those outliers. Outliers mean that specific response, that specific respondent whose response is completely away from the rest of the responses, hence we call it outliers. So remove this type of responses, because again it will inflate error in your data. Okay, it will compromise the variance in your data that you would like to have. To higher the variance, the better it is. However, okay, let's move forward. Okay, this is another table, and at the end of this presentation, I'll be sharing a link for the book to download. And in that book, actually, it's a PLS10 book, and which has various chapters. It's a here book that I'll be sharing with you, which has various chapters and about PLS10, how to do it, right to end. And I've taken this table from there. So if you have nothing else, just follow this table. Follow this table to determine what will be your sample size, right? Okay. Okay, so multicollinearity, we use VIF, various inflection factor, in PLS-SEM, in SmartPLS. And then common method bias is another issue. For that, we can use Herman single factor test or full collinearity assessment. I'll be doing full collinearity assessment in front of you in SmartPLS to show you how to do your common method bias check or CMV check within SmartPLS. Okay, so I believe most of you understand, but just to give you a recap, on the left side, you see here, I have 5 independent variable and I have cooperation here as a dependent variable. This is something we used to do in multiple regression. However, now with the help of PLS-SEM, we can do this type of modeling as well, where we have this independent variable. Again, this is dependent variable. independent variable, dependent variable, and this is a mediating variable. That means benefit may have a direct relationship with cooperation as well as a mediated relationship with cooperation through commitment. Likewise, so this is a mediator here. Likewise, in SmartPLS, we can do moderation analysis where we have, again, benefits has a relationship with cooperation, and we believe that the long-term orientation has a moderating role on the relationship between benefits and cooperation. So this is quite easy, mediation and moderation are become quite easy when you use SmartPLS or any PLS software. Okay. Okay, so take a look at here. Now, we're going to start now the actual work, right? And before that, I need to make you understand a couple of things. I've taken the same model that I have shown you in my previous slides. How much time we have? We have 10 minutes. I've taken the same model that I've shown you in my previous slide, but again, I would like to show you, I would like to tell you, I would like to enrich you on the language of PLSM. We need to understand the language of PLSM. And for that, now we understand this is we call independent variable. This is also called independent variable, and this is called dependent variable, right? That's a common. Now in PLSM, it's common to call this type of variable that I'm calling independent variable as exogenous variable, right? Exogenous variable. It's common to call these type of variable exogenous variable, and this dependent variable or a mediating variable. It's common to call it endogenous variable. E-N-D-E-N-O, endogenous variable. So when you are reading a lot of material about PLSM, don't be confused with the name of these variables. When they're referring to exogenous variable, that means independent variable, and when they're referring to endogenous variable, END, they're referring to either mediator or the dependent variable. Okay, if you're all set with that, let's figure out what do we mean by, there are two types of, basically we can do PLSM analysis in two steps. Number one step is measurement model, and number two step is structural model. Now, what do you mean by measurement model? Take a look at here. Here I'm saying that communication has a relationship with cooperation, and benefit has a relationship with cooperation. And then I'm saying communication has 5 items, 1, 2, 3, 4, 5. And then I'm saying benefit has 5 items, right? So these 5 items here, right? And these 5 items here, they are actually, which I call earlier, observable variable. And these variables here, cooperation, benefits, communication, these are called latent variable, right? So now, what is a measurement model? You see this blue box here. So first thing what we do, we check the reliability and validity of our data. When we do that, basically we check how much these items are reliable, how much they are validly explaining this concept of communication. Likewise here for benefits, likewise here for cooperation. So 2 steps for structural equational modeling, rather for PLSM. Number 1, measurement model, in which we will be checking whether our data is reliable and valid here, right? That means we'll be checking the relationship, some type of relationship between these item and this concept, between these item and this concept, between these item and this concept. Once we are done with these type of analysis, we're done with measurement model. Now we'll move on to the next step, which is we call a structural model. In a structural model, we are not concerned about reliability and validity. In a structural model, we are concerned about the hypothesis, the relationship between these concepts. Remember the hypothesis that A is related, A has a relationship with B, or A has a positive relationship with B. We are talking about that. So when we want to check, once we're done with measurement model, assessing the reliability and validity of our data, the next step is to check those relationships, right? So how we check relationship? By running a structural equation modeling. And based on that relationship, we decide whether our hypotheses are significantly or are significant or not, or have been accepted or not. So in measurement model, we run reliability and validity analysis. In a structural model, we run analysis to assess the relationship between concepts that we want to measure and investigate. So in a structural model, basically, this is where we determine whether our hypotheses are accepted or rejected. Okay. One more thing. This here, the part you see in blue, this is also called outer model. It's called outer model, right here. And this here that you see in orange or yellow color, this is called inner model. So we can call it a structural model or inner model. And likewise, we can call it measurement model or outer model. That's the part you see in blue color. Okay, we still have 5 minutes. Okay, you can see same thing happening here. And now these words, exogenous variable, endogenous variable, should not confuse you. Should not confuse you. They're pretty okay. They're pretty, simple. Now, what do I mean by endogenous variable? This is endogenous variable. This is endogenous variable. And we know the exogenous variable. This is exogenous variable. Again, this box here, this is the outer model or measurement model. Like with this box here, this is outer model or measurement model. And here in the middle, you see this is we call a structural model or inner model, right? I hope everybody is with me and they're able to understand. Okay, so a couple of more things. Often we refer mediation as indirect relationship and interaction effect as moderation. So all these terms we need to learn. Mediation, indirect relationship, they're referring to mediation. Now, what is mediation and indirect relationship? Like I showed you on my slide here. This is called mediation indirect relationship. That means the indirect relationship between benefits and cooperation through commitment. Even though direct relationship path is here, but it may also have indirect relationship, right? And here we are showing interaction or we call moderation effect. It's also called moderation or interaction effect. So let's go here. Okay. Okay, so the area you see highlighted in slightly, actually dark yellow or orange color, dark orange actually, see dark orange color. So these are the steps we need to take. In a simple PLSM modeling, number one, we specify the structural model, then we draw our concept, our variable on SmartPLS, and then we specify the measurement model. Then we, based on that, we collect the data. We collect our data. Then we estimate our measurement model, and then we estimate based on reflective measurement model. Then we estimate our structural model, and lastly, we interpret the results of our data. These are the steps we have to take. Where I've taken this picture from, this image from, again, from the same book that I would like to share with all of you. At the end of my presentation, I've given the link and I'll be sharing this presentation with Dr. Mehdi, and he should be able to forward it to all of you. Okay. Again, so let's start doing PLSM, and I think we don't have much time. We have only 3 minutes. So again, the reminder, when we'll be doing PLSM, we need to make sure that our missing values are less than 5% for single variable. I'm talking about single variable. Total missing values for single variable in our data should be less than 5%. Okay. And other way around, they say there are a couple of arguments. Some people say missing value should be total 5% in the total data. Okay. So then no highly skewed data, absence of outliers, and linear relationship. It's another assumption that if you are measuring a non-linear relationship, which essentially means, now let me see if I can draw. I'm sorry if I'll be drawing pretty bad, but let me try if I can draw. This is what, I'm sorry for the bad drawing because I'm using my mouse. So you see, this is linear relationship. This is linear relationship, right? Now, in other word, in other situation, we may not have linear relationship. What if our relationship is something like this? Something like this. Okay. Now in this case, from here to here, the relationship is linear, but from here to here, the relationship is not linear, not linear. So if you have this type of situation, you know you're not trying to prove a linear relationship, then it's not, you should not be using PLSM. In most cases, again, in I would say 95% cases, research I've seen in marketing, in HR, in management, in entrepreneurship, in the street, most cases, there are linear relationships. It is actually a linear relationship. Or we say A has a negative relationship B, then again, it's a linear relationship. Okay. So this is what we're doing. Number one, we'll be running a measurement model. And in measurement model, we'll be doing outer loading. And then we'll be checking outer loading. Then we'll be checking reliability. Then we'll be checking multipolarity. And then we'll be checking two types of validity, convergent validity and discriminant validity. And then we'll move to PLSM structural model, right? So I guess it's almost time, and I'll give it to brother Dr. Mehdi because he said after an hour we should have a break. So let's have a break, and when we come back,